Okay, so problem two. Problem two is asking the molar solubility of PbCl2 in a zero point 0.1 molar solution of NaCl is 1.7 times 10 to the negative 3 moles in a liter. That is 1.7 times 10 to the negative 3 moles of lead chloride will dissolve in 1 liter of the solution. What is the KSP of lead chloride? All right, so like the first equation, we will start by writing the dissolution chemical equation for lead chloride, and that is PbCl2 goes to, this is solid, goes to Pb2 plus, which is aqueous, plus Cl minus, 2 Cl minus actually, which is aqueous, because there's two balanced chemical equation. The next step, we are creating an ice table to find the concentrations of each of these substances. We can ignore lead chloride because it is a solid, and we can assume that the concentration in the beginning, the concentration of the lead in the beginning is 0. However, because the lead chloride is being dissolved in a solution of 0.10 molar NaCl, we can infer that there are 0.10 moles of chlorine floating around. So that is 0.10 molar. That is a bad molar. Okay. Now, we can add in NX plus X to represent the change in the lead, and a plus 2X to represent the change in the chlorine, because for every 1 lead, there are 2 chlorine. And then the final concentrations we have are X and 2X plus 0.10. Okay, so looking at our KSP expression, KSP equals the concentrations of products over the concentration of reactants. We can ignore the reactants because it is a solid. So KSP equals the concentration of Pb2 plus times the concentration of Cl minus, and the Cl minus is squared because it has a coefficient of 2. Now, we can replace these concentrations with the values we have here, which is X times 2X plus 0.10. Okay. Now, the molar concentration, the molar solubility was given, and that value is 1.7 times 10 to the negative third, and the molar solubility is X. That is that value. So we can actually replace the X's in this either before or after you simplify, depending on what you want to do. We can just replace it with 1.7 times 10 to the negative third. So what we can actually write this as is KSP equals 1.7 times 10 to the negative third times 2 times 1.7 times 10 to the negative third. That's a squared. Plus 0.10 squared. And if you plug this into your calculator, you get a KSP value of, 1.7 times 10 to the negative third times 2 times 1.7 times 10 to the negative third plus 0.1, that's squared. 1.81 times 10 to the negative fifth.